Alright, so here we are. We're making a mess, and this time we're going to turn a little bar of aluminum, which I took a video of a little while ago, and we looked at it, and it doesn't have much structure. It's random, it doesn't make rainbows, and it's sitting in some AUPD dust. This is kaolinite clay from Georgia. Company sent it to me, and I have added borax, about 20% borax, into the dust. And the dust is so very fine, it's molecular. And it's drawn into the aluminum when I heat it up. So we're going to, whoa, whoop, heat it up. And there goes the borax starting to melt, and blows sodium all over the place, kind of makes soda ash as the borax starts to move into the metal, and what it's doing is bringing the AUPD with it. Okay, and as soon as it starts doing that, it's melting the aluminum away, because aluminum melts at 650 degrees Celsius. Flame is 2500 degrees Celsius, which is where aluminum vaporizes, turns into a vapor and disappears. Literally evaporates like water. But it's bringing the AUPD with it, and you can see that it's still getting some of that sodium, but it's starting to look a little goldy now. Alright, so let me turn my camera off. Alright, we're gonna heat it up now. Make it glow. And we're evaporating aluminum. That's what's coming out in that yellow stuff. That's the sodium and the aluminum. So, and that, as long as that's in there and coming out, it's keeping the temperature down. But now it's starting to go up, see? Now we're getting rid of all that aluminum. Look at that. And now we have AUPD. And you can see structure starting to happen, you see? There's structure starting to happen as I move the flame around. And it's taking the old shape of the aluminum, but turning it into like flower-looking things and stuff like that weren't actually there before. And so now we have AUPD. Far out, huh? That was easy. And, this is, I don't know, I think 4 ounces is what these little bars start out as, is aluminum. It's not aluminum anymore. It's real hot right now. We don't want to like touch it. It's still doing what it does. There's stuff evaporating off, and it's bringing in more gold as we're looking. Because the gold is actually melting and boiling off too a little bit. Gold's melting point is down around 1050. So until this cools below 1050, it's going to evaporate gold also. And that movement of metal happens at temperature, because inside of there, as soon as it starts turning into AuPd, and even when it's aluminum, the molecules are pretty far apart. And so metals move through each other like liquid, right? Because they are. They turn into a liquid and they move towards the heat. And I didn't make that up. My father taught me that when I learned how to solder plumbing together. And I've welded and brazed in auto shops all of my life, and that's how they work. Metals move towards the heat. When Max Planck worked out the laws of thermodynamics, he was not, I think, a welder. This is part of what happens when you go to schools that are for technical and academic excellence, but you don't actually like work for a living. And so, the kids in Germany that work for a living follow a different academic track than the kids that are college bound. And so, Max Planck didn't know this. And I'm sorry he didn't. I didn't make that up either. I didn't make that up. Max Planck is responsible for most of our thermodynamics and stuff, and he won the Nobel Prize in 1900 for his work with black body radiation, which we just saw. It was a body that was not radiating before I started heating it up, and when it got hot, the temperature could be seen in the red color of the metal. And that's basically what his math shows, and here it is. It's cooling down, and I will put you on hold. So here we go again. I'm going to try to hold the lens still. Maybe clean it off a little bit. Pouring water in to my dish. Putting the phone down. Fuck. So we don't pick up blocks of hot metal until we cool them down. And they cool down pretty quick. Cool, huh? Yeah, that's fucking cool, man. Not too cool. I'm not gonna put my finger on it for a while. So we'll come back. Alright, so I'm feeling lucky. Still pretty warm. Alright, remember what color it was when we started out? All nice and silver and aluminum-y looking. And I didn't like burn it. I didn't burn it. If you've ever melted aluminum, you know that it just melts when you put a torch on it. Unless it's sitting in AUPD dust with borax. If you just put it in AUPD dust, it doesn't do anything. It's inert. You gotta have the borax in there. And you know, Boraxo hand soap works just fine. Boraxo hand soap is probably available in almost every hardware store in the entire world. And what we have now is not like dirty metal, not even a little bit, right? I've got a nice little baby wipe, brand new baby wipe. And we're gonna wash it off. See what it looks like on the sides. Alrighty. And it's kind of goldy looking. And we're gonna turn the light on. And we're at 10. And we've got rainbows and gold. And the kind of a cubic structure. Let me back out here again. Isn't that pretty? Wow, huh? Alright, let's see what it looks like when we back it out. Okay, this was the bottom. Sitting in the dust like this. And the gold moved towards the heat where I was using the torch. And not so much back here. Just exactly where I was using the torch. Because that metal is moving towards the heat. And it drew the AUPD with it because gold has a lower melting point than palladium. Palladium melts up around 1550. Gold melts around 1050. So this was a vapor or a liquid moving through the metal, through the planes of cleavage. And it's now got a cubic structure. And those planes of cleavage allow the gold to pass through. And there's a thin layer of gold between each layer of palladium. So it's not just palladium, it's AUPD. And this is a true room temperature superconductor. Welcome to the future. It's a little gift from the Starfire family to the people of planet Earth. This does not rust, it does not wear out, it doesn't oxidize, it's bright and shiny and beautiful, it's malleable, it's lighter than aluminum, stronger than steel. It is the single most abundant stuff on Earth.